Okay, so welcome everyone. Today's question of the day is count the number of possible triangles. So, as the definition says, a triangle with three given sides is only possible if any two sides is always greater than third side. मतलब अगर triangle की side A, B, C है, then A plus B should be greater than C, and A plus C greater than B, and C plus B greater than A, right? सारे possible combinations. तो the brute force technique for this approach would be कि हम चुपचाप से सारे triplet form कर लें, right? And after forming all the triplets, for each and every triplet, we'll just check if um, array of I plus j is greater than k, and so on and so forth, right? So let's just code the brute force technique, that is k equals to j plus 1 to k less than n minus 2 and k plus plus, right? And here we're gonna just check if array of I, let me write all those three conditions and then we can resume. Okay, so here goes our brute force technique, that is counting all the triplets and checking the triangle property, that is a plus b greater than c and a plus c greater than a, and so on and so forth for all the possibilities, right? So we can see, okay, reset, not reset. We can see that the particular brute force technique has been successfully compiled and test cases have passed, but I think we'll get an TLE. Let us verify it before the submission. Okay, so there is a TLE, right? The reason being that we are coding this solution in n cube, and n stands for 10 power 3, and 10 power 3 cube will give you 10 power 9, that is greater than 10 power 8, right? Okay. A video above must be popping up now to trick the TLE, and there you can see the 10 power 8 logic and how we have compared just now, right? Okay, so let's just get ahead with the optimized one. So again, if you see this question, So if you see this question, हमारे पास एक triangle है which has A, B, and C, right? And what we need to compare that A plus B greater than C, and B plus C greater than A, and then what A plus C greater than B for all the possible combinations, because this is the definition of a triangle, like a three. Yeah, so that's the definition for being a triangle. Okay, तो हम यहाँ क्या कर सकते हैं यार कि as we can see that we are always seeing that A plus B greater than C and something like, तो आप देख रहे हैं यहाँ पे कुछ पेयर सम जैसा हो रहा है, right? We are forming a particular pair and we are checking if it is greater than your target or like some other value, right? So again, the prerequisite question for this particular question would be pair sum problem, right? And in the pair sum, the optimized technique we do is via the two pointers technique. And two pointers works when you have array as sorted, right? Array as sorted. So this question has now two methods. Method two, you can do it with binary search, because if the array is sorted, we can apply binary search as well. Method three is again the two pointers, the sorted technique, right? So you may be wondering कि हम इस stage पे कैसे हैं, like how were we able to figure out कि there was a two pointer technique, right? So the reason being is कि you can look up to our DSA sheet. I just launched it on 31st of December 2024. It has the prerequisite bunch of question of 360. तो मैं हमेशा बोलता हूँ यार, एक prerequisite question हमेशा आपके दिमाग में होना चाहिए, and you should keep on revising it, right? And उसके बाद once you know that what is cadence, what is the standard algorithms, the BFS, DFS, Prim's, Dijkstra, two pointers technique, and uh, some various several questions which is named as the standard ones, अगर वो पता है, then अब जो क्वेश्चन आता है कोई उसका वेरिएशन, तो हम उसको सॉल्व कर सकते हैं, राइट? ठीक है, तो कमिंग बैक टू दिस पॉइंट, तो अगर ये एरे हमारा सॉर्टेड होता, लेट्स से इट वाज if we sort this array, तो हमारा क्या होता, 3 4 6 and 7, right? So if it is sorted, then what can you say about the particular triplet? Can you say that it will always be A less than equals to B and less than equals to C? All the triplets will be following this order, and once the triplet is following this order, can you say that can you say that if A, I am saying that if A is one sec, that if A is less than your C, then I can also say that A plus B will also be what to say? Hmm. A is less than C, and similarly B is less than C. Then I can also say that if C is greater than your A, then C plus B will also be greater than A, and C plus A will also be greater than B, right? Using using this inequality, we can refer this much. So out of three conditions, we already checked tw two conditions, or you can say we do not need to check two conditions out of three, because the array we have sorted it. The only condition we need to check now is that A plus B should be greater than C. This condition has not been checked. Why this inequality, हमें बस ये check करने की जरूरत है, right? So there goes our two pointer technique. तो हम यहाँ पे array को sort करेंगे, and after sorting the array, you will have 3 4 6 and 7, right? And we need to decide our low and high pointer. So this will be our low, this would be our high pointer, and this would be our C, right? So this would be our range of A and B, possible A and B. So this would be our potential pointers, right? तो C की वैल्यू आप देख पा रहे होगे कहाँ से कहाँ तक जा रही है, 0 1 2 3, राइट? यहाँ से 2 से लेकर के लास्ट तक, या फिर आप कह सकते हो लास्ट से लेकर के यहाँ तक, राइट? तो C की वैल्यू के लिए हम एक फॉर लूप चला सकते हैं for I equals to 2 till I less than n and I plus plus, right? And your two pointer also will always be in range of A pointing to 0, right? तो आप low value को 0 point करा सकते हो and high value to just beside C, right? So it would be, let's say, high equals to C minus 1, right? C minus 1 लिख देते हैं, yep. ठीक है, and इन दोनों के बीच हमें टू पॉइंटर लगाना है. So what would be the logic again? What is हम एक current sum बनाएंगे. Sum is nothing but array of A plus array of B, right? And we need to check that array of A plus array of A and array of B should be greater than array of this index C, right? Now let us assume for this case it is actually greater, right? 6 plus 3 9, which is greater than your 7, right? So can you say set for all the elements present between this A and B will also hold this inequality true, right? Let's say your previous A was this, right? 3. And now and if you change this A to this one, 4, right? If you change to another element, let's say it was, since it is sorted, then the only element possible in this 4 and 6 would be 5, right? So if 3 plus 6 was greater than 7, then 4 plus 6 will also be greater than 7, and similarly 5 plus 6 will also be greater than 7, right? So we can say that in this case, result will be taken from our difference of the low and high pointers, right? That is the total number of triplets getting formed between it. So I can just say here that result plus equals to B minus A, right? And what if my sum is, there are two possibilities now. If sum is greater than your target, let's say your C, and if is lesser than C. Now we have ensured that all the elements would form, right? This particular, we can shift all the pointers from A for all the elements present between A and B, right? But we have not ensured that what if we move the pointers from the right hand side, that is B going toward inwards. So can you also like say for certain that if I move B here, then 3 plus 5 8 is greater than, like, we can say okay, it's now available. But if we move further inward, B moves to this point 4, then 3 plus 4 7, and 7 greater than 7 will not hold the inequality, right? So if we move A towards it, that is the reason, then we got the resultant answer as B minus A. But if we do B minus minus for all such available potential pairs, then we cannot guarantee that we do not need to check, we cannot guarantee that, right? So in that case, have your resultant and do a B minus minus, right? Correct. So there goes our final code as the first step as iris.sort, and then what we need. N equals to r.line equals to 0, and then we are traveling from I equals to 2 to less than n, and declaring our high and low pointers. Again, the two pointer search is happening here. We already discussed if the condition is satisfied, we need to get all the count of the elements present inside the HNL as well, and we do a high minus minus. Else, if the sum is lower, that means we need to increase the sum, and that means we need to increment from the left hand side, that is L plus plus, and at the last we'll return the answer. That is it for this approach. What would be the time and space? So arrays.sort itself will take n log n, and this for loop will take n. That will give you the overall worst as n log n, and that is it for this video. To learn, keep learning, keep doing. Bye bye, and take care, guys. And do not forget to check out our playlist, and you can just come to our playlist section of our YouTube channel, and you can do a control F, and you can clearly search whatever data structures you want to study, that is two pointers technique or greedy stacks, queues, arrays, everything would be here. So do make full use of it, and till then uh, we'll meet again in the next video.